So, right, welcome everyone, even though we already seen each other for some time now, most of you. Okay, so welcome to Link Data in Sweden. So the acronym is LDSV, which is a bit weird because it's with W in Sweden. But that's the way we roll here in Sweden, always in English. So we've been doing this Link Data, what we call it, symposium, this year. Before we've called it event, maybe a conference. It's a bit hard to define what it is, but I mean, we are basically meeting a lot of people here with Swedish base, which is interested in Link Data. And we started already in Stockholm 2012, and it has been a bit different organizers at that point. I think me and Hannes we were at that time at KTH, started it together with, I don't remember who else, it was Eva and from Linköping and Malmö and Linköping. And we found that this is a good thing, we want to keep it up, and we have since had, is it now 6, and now this is the 7th time. So you can see, we have now created one web page which is collecting this symposium series of events. The data or the information about the agenda is reachable from each one of these links. There are sometimes only the actual Eventbrite invite. So we've had a bit of different ambitions regarding how formal doing web page for each time. Anyway, we will try to keep this web page up for the future as a central point for this symposium series. Moving on to, well, what is the scope here? So you're welcome independent if you're a practitioner, an academic, or an experienced or new in the field. And the purpose is both bringing people together and exchanging experiences. So we should be a little bit of a community. That's the goal. And we will, at the end of the day, talk a little bit about how to proceed with that community. Should we do anything else? So, well, let's revisit that topic later. So let's move over to this year's instance. So you probably have seen this already. I just want to say that it's too late to register now. We have live streams below, and we have some viewers already online. We had, I think, 7 already in the morning. That's great. We have the agenda, and nearly every talk has a short abstract where you can go, and I hope that we will be able to have some kind of links to slides afterwards. So presenters, please, if possible, send me slides or links to slides. We can put them up here. It's nice to have them. And the live streams will be available, of course, afterwards as well. Should I say something about the talks? We have a little bit of focus on, yeah.
If you can just open, I can go.
I leave it to Fernanda here, so she. I don't steal her speech.
No,
so.
I just
wanted
you to open it. It's your honor.
I think I will leave it to you now.
Okay.
So.
Thanks. I just wanted Matthias to open the symposium, as he's the one experiencing this event. I'm relatively new to the group. As our agenda today, we just want to thank our hosts, the SciLife Lab. So Johan Rung will say a few words. It's our pleasure to have you here. Thank you so much for having us. And then we'll have one presentation, and we'll have a little short leg stretch. And in the morning, we'll have the bio presentations. Lunch will be served just outside here. And then in the afternoon, we'll have a section with presentations again, more city, buildings, people. And then we'll have a discussion. Everyone who registered wrote down if they had any ideas for the discussion. We'll kind of do a 5-minute, Matthias and I will moderate the ideas for us to see if we can come up with 2 or 3 well-defined themes for our discussion, and then we either split in 2 groups in this room, or one group can go outside, and we'll just carry an informal conversation about a specific theme that people are interested in, and then we're going to come back for 3 more, a little bit more varied topics, and finish again with another discussion. And those who can stay, tonight there is a social event. So that's the overview of our agenda for today. So I'll leave the floor to Johan, our host.
All right. So, see if this works. I don't know. Do you hear me talk kind of loud?
Yeah. Should I turn this off?
Thank you.
I don't know. I'll figure out how I turn that off.
I guess it should be turned on.
Okay. Yeah.
Och det är min fortfarande, va?
Yes.
Right.
Sorry, while he set up, I forgot to say the presentations are planned to be 15 minutes plus 5 minutes for questions and discussions and exchanging the equipment. So I'll stay up here training you if you go over 15 minutes, but I'll try to warn when it's 2 minutes to go. So about 13 minutes I'll try to sign to you for presenting. I'll shame you with 15 minutes and I'll definitely cut you off at 20.
Here is an alternative way to connect to a Wi-Fi, which Matthias brought through his 4G.
All right. Thank you. And very welcome to Uppsala and SciLife Lab. Very happy to have you here. I'm Johan Rung. I'm the head of the SciLife Lab Data Center. I'm just going to do a quick introduction about SciLife Lab itself and the data we produce here. So, SciLife Lab is a national infrastructure for environment and life sciences, right? And we're actually formed in 2010, and we have functioned as a national infrastructure by law since 2013. We have 40 different technology platforms in life sciences located around the country, most of them in Uppsala and in Stockholm, and they are distributed around 8 different technology platforms. We have around 450 infrastructure staff. These are staff scientists that work in the service platforms, providing services for Swedish life science researchers. We also have affiliated researchers. It's around 1,000 people in different groups who come in and provide research, do their own research affiliated to SciLife Lab. We have programs for SciLife Lab fellows. We have some other programs for different types of science in SciLife Lab. The funding we have is around 450 million for the infrastructure. So it's quite good funding to provide the services for this community. The platforms, there are 8 platforms. It's bioinformatics, cellular and molecular imaging is one platform where we see data is growing very, very much in the imaging platform. There's chemical biology and genome engineering. Diagnostics development is the platform that worked very tightly linked to Swedish healthcare. For instance, what they do is bringing in new genomic type assays into healthcare for precision medicine. That's one big area for the diagnostics platform right now. There's a platform working very closely to industry for drug discovery and development. There's research genomics. They don't do the clinical part. Well, of course, many projects have clinical applications, but they provide the large-scale output for genomic data. They are the ones producing the most data in SciLife Lab right now. There's a platform for proteomics and metabolomics, and one for single-cell biology. That quite a lot of genomics goes through the single cell. This is also one reason why we see data is growing so much right now, because we used to provide a lot of data for one sample. Now we provide a lot of data for every cell in that sample. The way we generate data is basically that the different platforms provide different types of support. Not all platforms provide data as their deliverable. Some provide zebrafish strains, some maybe provide antibodies, could be all sorts of stuff. But for the platforms that provide data, they sort of put it out to the users, deliver data to storage in the servers or into structured databases. But what we see, and I'm going to talk a little bit about how we see the future. I mean, right, with Scilab Lab is producing this, but delivering it out to the data, which means that much of the coordination of this comes down to the end user. What we would like to achieve is something where the user, the researcher, sits in the focus. Because now the user have to come to us to ask for one type of support of data. And you get the data delivered if you get the support. Then you have to go to another platform to ask for support somewhere else. So what we would like to do now is to go from this to something that is more coordinated from a project point of view, so that we can support the projects from start to finish, to make sure to get the best possible scientific impact of the data generated. So there's a number of improvements that we can see. We would like to improve the coordination among the platforms. We would like to track data from the start. This thing of data management plans is becoming very, very important to deal with, so that right from the start, researchers need to know how to deal with the data all along the project, from start, from production to publication and reuse of the data. So we try to track the data, track the impact of the data, to facilitate new studies coming from the data that has been produced here. We would like to get a good overview of the impact simply. So why a data center, the unit that we have set up now, and it's just 1 year old now, and we're trying to build this inside Scilab Lab. I mean, data is one of the most concrete products that comes out of this. All the funding that goes in, taxpayer money goes into this. We have a responsibility to make sure that we get the maximum possible impact out of the data that comes out. We need to have some kind of accountability for what's done and for what the researchers do when they use us as a service unit. We need reproducibility, openness, transparency, and this is something that's required not only by good standards, but it's required also by law. There are legal requirements for this. Funders increasingly require that you have an openness and publish your data just as well as your articles. And of course, journals that will also require you to publish your data, or you will not get your article accepted. So of course, data has a lasting value. So this is why we need to take care of this. So we think that the central service inside Scilab Lab, what we have set up now, is going to facilitate these kind of cross-platform activities and provide a better IT environment for life science data production. Especially here, I mean, human data, anything that's sensitive. Now when the legal field is we have a GDPR, which is the new law for personal data, we need to take care of this so that anything that is clinical personal data has to have very good security and handling for how you access it. And this is also something that we take care of. So our goal is really to raise the scientific impact of data, to provide a good environment, and to promote open science. And I'm sure you're going to hear a lot more about this during the day. So the way we, as a data center, work is that on this side, you can see this is basically a Scilab Lab platform, the scientific platforms that produce the services, that serve towards the left, the end users, researchers, academia, industry, healthcare. The data center serves the service units primarily to make sure that there's a good environment for data production in Sweden. So we have a number of activities we work on with coordination. We make sure that people talk to the right other people. We handle data access and security, where to archive data, how to archive data, how to serve data out from the archives, and to track data and track the scientific impact of what's going on here. So we try to see us as sitting in as sort of helping projects from the data production side, from the start where you design your studies, to generating data, analyze the data, annotate your data, and sort of the whole way through afterwards with archiving and publishing and also reusing the data. It's very important. And one model of that this has been working out is that, classically, we produce data, hand it out to the researchers. Researchers do their stuff, analyze data, and publish. And after publishing, you archive your data. And we would like to change this model slightly. So, instead, we produce the data. Directly from data producers, we archive the data. We give the researchers access from the archive. And then you publish. And this is something that, in this case, we know that the archiving is going to be made so that you can actually access the data afterwards, instead of handing this to each researcher to solve it independently. So what we would like to see is a proper national infrastructure for storage and archiving. And this is something we're working towards, and we have this distributed storage system coming up around the country, actually. So in the next coming years, I think we will start seeing this kind of model. The difficulties in using data right now, there's a bunch of different issues. First of all, if we're talking sensitive data in particular, because genomics is really the main thing, we produce around in the order of 2 petabytes of genomic data every year, and around 3/4 are on human. So it's a lot of sensitive personal data coming out of us, and we need to take care of this in a good way. The infrastructure in the country is insufficient for this. There's a lot of good infrastructure, but much needs to build up, in particular when it comes to storage and to integrate data. And I think this is something that this workshop will talk very much about. There's a lot of requirements now from funders, journals, to publish them data, but at the same time, you need to protect the privacy and of the individuals. So this can be seen as sort of 2 different sides that we need to solve at once. Both making things public, but also keeping the privacy and security. So what we can see is that there's actually a bit difficulties right now in both regulatory and when it comes to infrastructure to build these databases, build the services that deal with sensitive data in particular. And there's actually a lack of support functions at the universities, what we see, for data management issues for individual researchers. Where do an individual researcher go when it comes to support for data management? You have the inspections side, the auditing side, Datainspektionen, which is very strong. But on the other side, we don't really have something that can support researchers. So when it comes in particular to sensitive data, we have this kind of issue here. We have researchers need to do their work, need to work on systems provided by IT security experts. And these systems need to be designed in a way that is in accordance to the law, of course. But we wouldn't like every researcher to have to be an IT security expert and a lawyer. So what we would like to make sure is that, based on the law, systems are designed and set up and made accessible in a way so that researcher can access them, knowing that if they access them in the right way, they are in accordance to the law. They're not going to have this problem. So today, this is not really happening in this way, but we want to work towards this way, right? So there's some work to do. And of course, you have heard this a million times, but what I can tell you now again is that there's a lot of data out there. I always show this for when I teach, because I think this is quite telling. This is a nice picture taken by the Hubble telescope that you all have heard of. And the Hubble telescope provided, over the span of the first 20 years, around 45 terabytes piping down of impressive images. Fantastic data. 45 terabytes coming down. DNA sequencing. We do the same amount in less than a week right now. And this slide is a year old. So, I mean, there's a lot of data coming. And again, we need transparency into this. We need to see what's going on. We need to follow the research process to make sure that things are done in the right way. We need to have reproducibility, that you made data accessible and the methods, and you have annotation for both the software you use and the data management part you use, and the whole chain from production to end, so that we can know that you can reproduce and follow what's going on, to have a good accountability for the science. This is why we say make data fair. Fair, I'm sure you all heard of, findable, accessible, interoperable, and reusable. It's something that comes back again and again, that we try to set up systems that makes data fair. And I would like to finish just saying that open science, it's not exactly a new thing. It's been around for quite some time to actually share your data. That's how science works. So I'm very happy that you're here. And when it comes to data side, sharing is caring. Good. Thank you very much. I can take any questions, but I'm sure you want to move on as well. Yes?
Purely a technical interest, but what kind of technology would you use for storing this huge amount of data? Is it well, big data, things like Cloudera, Hortonworks, or what kind of technology do you base a system like this on?
Well, I mean,
Huge amount of information.
So right now, I mean, where we store data mostly is actually at the compute side. I would like there being so at Uppmax, at the SNCC systems, they're basically storage linked to the compute servers. That's, you know, it's not huge amounts, in the order of a few 5, 6, 7 petabytes, you know. That's reasonable. What we would like to see is to build the very, very big systems. And there's an initiative now on a distributed compute service that soon is setting up, where Swedish universities are asked to become nodes in the national distributed storage network. And that's set up with OpenStack and Ceph. Anything else?
Well, sure, but if you archive the data before it's processed, before researchers look at it,
Yes.
you're going to be storing an awful lot of garbage as well.
Yes.
I mean, the whole run said, yeah, that whole run didn't work at all, because I know I'm an expert, and it's gone.
Yes.
I think it's going to make the storage problem so much.
No. I mean, obviously, you can also clean that stuff, right?
Okay.
But it's
That was really the question. Can you go
Yes.
back and tag it? Can you annotate? Can you manage that and say, yes, this is here, but it's garbage, or we need to delete that, so you can go back to it later. It's not just like write once.
Yes, but I think you have to be really careful about deleting data too early. So I think that's actually providing the services to actually put this in place and make it permanent, or possibly permanent. And then you can go back after your study has been published to do some cleaning or sorting out.
But
That's
if you can tag it
yeah.
and annotate, that's good.
Yes. So, this. All right. Ah, I'm stealing the sound. Here you go.
Thank you so much, Johan, for having us and for keeping time. Our next speaker is Olof. I will let him introduce himself. Instead of reading his title, I will let you go introduce yourself. For the next presentation, we have a little bench stretch after this, leg stretch after this. But for the next presentations, I will try to moderate any questions, and someone will take care of getting the presentations or switching the computer, so you can just come up during the questions if you're the next presenter. Sorry, thank you.
Okay, thank you for the invitation. And I hope you will hear me. Otherwise, you can shout out and say that I should be louder. So my name is Olof Korsvall. I'm a historian, more specifically agrarian historian, or studying rural history, medieval history. But I also have this interest in informatics and computer scientist. And I have now a project with linked data approach on historical material. And this is concerning the geodata aspects of historical settlements. And I will explain more what this is all about. And right now I am at the National Archives in Stockholm. In Sweden, we have a unique collection of maps. We have the oldest large-scale maps of villages, farms, etc. ever produced for a whole country, a land survey. And these were made in the started to be made in the 1630s, and during the 17th century we have 15,000 maps, and they look like this, you see on the screen. Collected in books, only one copy exists for each map. Totally unique, and they are like a time machine. You can go into the landscape of the 17th century, into the detail in a scale of 1 to 5,000, and understand how the landscape actually look. You can see here the farmstead, the location for each farmstead. You see the fences, all the acre are mapped in very much in detail. The meadowland, the roads, etc. A lot of details, and also the properties, all the boundaries separating lands are in the maps. Very fascinating. They have been used a lot in research, but not so by so many people. And I was involved in a project before. We identified all the maps existing in Sweden from this time. They are separated in some different archives. And we did this in a very traditional way. We created a database, and we transcribed all the text, and we scanned all the images, and we built up a database with a lot of quantitative information you can get from the maps. And I made my thesis also related to this database. And now we realized that we put coordinates for each map. We put a coordinate for the settlement. I mean, the village itself has a coordinate, very precise, the location. And we realized that these coordinates, the historical places, they were suitable as objects on the semantic web. We can reuse them, and we can relate them to other documents, which also has place names and geographical information. So in this project, the idea is to publish what we call the historical settlement units. And I will say shortly what I mean, because the linked data, as Matthias told, is about things. And what's our thing then? Our thing we want to contribute with is the historical settlement unit, which we defined could be a village, hamlet, single farm, a manor, or a town. But it's we say that this is the building blocks in the society, in the old society. Medieval society and early modern society, it's available in a lot of registers from this period. And the idea here is that we can put a coordinate for each location. And you can see here, actually the location represents an area. There is not a point. It doesn't point to an object really in that sense. It points to this area. But the area in this case doesn't really change over time. Here is a map from 1633 from Örberga. And if we go 100 years later, there is still the same area. We can use the same point representing also this map, a later map. So from this time, in medieval time until early modern time, the same areas exist. So we have put a coordinate representing the area, and we call it historical settlement unit. And there are some criteria for this. We have a method also for how to put the coordinate to get it more accurate. In the project now, we want to establish this list of historical settlement units with the coordinates, and we want to develop a linked data service so others can reuse our coordinates, so they don't need to create their own coordinate for the same thing. So there are a lot of coordinates for place names that are being used. The land survey has coordinates, and there are different services using coordinates. And all of them use different coordinates for the same things. So it's a bit confusing. And that's one problem with those coordinates. They all have different coordinates. Don't ask me why. And the other thing is that we are historians. And we have the old landscape doesn't follow today's landscape. There's so much change during the time, especially the last 200 years. So a lot of those coordinates are not relevant for us. That's why we need a historical coordinate. That's why we created the historical coordinates. And so far, we have defined and located, put coordinates to 24,000 such historical settlement units. And as you can see on this map, they are distributed pretty much in the all parts of Sweden. It doesn't cover every part yet, but about 50% of the settlements that have exist in early modern time. And there are some different colors here because we have derived the coordinates from some different archives, but I can explain later if you are interested. And short, just to how we set those coordinates. Well, we have done it manually. It's time consuming, but we want to have it exact. We want to do it just one time, and so we put a lot of effort into this using GIS, going through all very different maps we can find and try to interpret the location from the oldest map to a modern system. And now we have also going into the linked data model, and every historical settlement unit can be represented as an RDF file. And our approach here was to have it kind of flat and concentrated to our things here. The place name, the identity, the settlement unit itself has a URI, and as an identifier, we have just a number. Doesn't really mean anything, just a number. And there is a pref label, and there is a creator that we also identify, who has created this coordinate. And we distribute different coordinate systems, and a source for the coordinate, and a coverage or accuracy for the coordinate, if it's well defined or more unsure. So it's a kind of metadata and some references for each settlement unit. And what we want to see now is that there are so many databases that has place names, historically relevant place names. We want to see them that they can reuse our coordinates into their systems. And then, I mean, we want to get to this more approach with, we try to link the informations, not just place names, could be other names and things, but we have a very well-defined historical coordinates. And for an example, we have other databases with the medieval documents, the oldest written documents at the National Archives. So one approach would be here we could use our coordinates to relate the place names that appear in those documents to the maps that we have used to set the coordinate. And in this case, all the legal documents has their own database. We could add our identifier into this database directly. But we also find out in this project that there's been so much work on such things already. And for example, there's many standard works that has been going on for 20, 50, 100 years or so that has already gone through all the sources and tried to find out the relations. And these books, these standard works, they actually works as a linked database, but they are printed and they are called standard works. And here we have all the references, all the sources, all the place names, etc., described and pointed out. So we realized quite soon that, okay, we want to use those works as the base, as the foundation for our linked data model. So we expanded our model to be more not just the settlement units, but also some source materials and some of the events, etc., and sources that appear in those standard works. And our workflow has been that we have scanned and made OCR readable PDFs of those books. And the next step, we converted them into XML TIA, Text Encoding Initiative, readable, machine readable XML, simply because that's the standard XML structure that are used in our field. And the next step is to make a script to convert it into a linked data format. For in this example, we use the events that has been described in those books related to the places. We can relate the event in an RDF model connected to our coordinate. And at the National Archives, we don't have any linked data platform, or haven't really published any open data, more or less, until recently. So we used the Meta Solutions platform for this project. And it gives us an administrative interface we can use to review all the data we have harvested into our RDF model or a linked data model. And it's been, if you remember Matthias' image when he described different ways to make linked data, there was the second option, where do we have a database, we convert it into RDF as using the platform, but we keep our database at the same time. So all the data is stored in the databases, but it's converted into RDF. When we have our data in the RDF format, we can now start to reuse and make applications on using the RDF format. And we just recently started to use this, and we have, for example, now we can make a quite a simple web page using a WordPress, and we could add the RDF, the basic historical settlement unit. All the information can be displayed as one part, but we can also add the parts we have added from the standard works. The events related to this place can appear also side by side, and we can have a map pointing out the coordinate. All by using the platform. Another thing we started to do was to have some work together with the National Library, because they have a lot of images related to those places we have coordinates for. For example, they have those images of made by Erik Dahlberg, very famous from the 17th century, Svecia Antique. And we could then add the coordinates directly into this library system and say that this image of this old church here, which is in Gamla Uppsala, we have the coordinate for Gamla Uppsala, and the next step here, which we haven't done yet, but we want to do, would be to add the coordinate for this place directly into the library system, like embedding our data into their system. Because they don't have any coordinates, and there is no meaning for them to add coordinates if we already have the coordinates. So, and on the other side, we can reuse their data into our proof of concept here, where we present our whole register. We could add not only the events from the standard works we added, but we can also add the images that they have put it out as an open data, and they can now appear on this web page. And we want to continue to reuse our coordinates into other systems, and we started to work with people who are very molded within the Wikipedia world and also other databases related to geodata. We have a Sparkle. I haven't really tried it yet, so I will not talk about that. But of course, you can also now do this filter and selected questions related to coordinates, which we are very much looking forward to try. And I'm also want to develop a WebGIS for all our data. That's a little different thing, but that's something that will come. And we plan to launch Tora as the first step later this year. This proof of concept is running, and all the data is the platform, etc., is running, but there will be more to come. Yeah, I think that's, well, I can also add this, that we see a kind of great use for the historical maps. Our first project that was kind of limited to a few researchers. Now we see, when we started to use the linked data approach, that we get connections with researchers in different fields. There are people in the planning also interested in using coordinates. There are local history research, genealogical research, place names research, and they are now we're getting much more interest from various fields. So yeah, that's all for me, I think.
Thank you. I think we ended up without any time for questions, but we have a 10-minute break now. So people may feel free to start getting up if they want, or go to the bathroom. So people can get up if they want. We're officially into the break time, but maybe there are some questions for Olof.
You're using points of reference for each city, or what you call it, settlements, not areas. Why did you make that choice?
In order to make this effective, to create the polygons, the areas, that would have taken, in that case, we have maybe done 200 or 300 settlements at this time. Now we can create basically the whole on a national scale. But there is also another answer to that question. It's basically that it's almost impossible to recreate the lines in an exact way. So that will be much more kind of interpretation, and that's something that every researcher can do themselves, and try to interpret where the boundaries should go, and etc. So this is a more straightforward, it's more easier, it's more reusable, I think, to put same coordinates, points.
Maybe we can approach Olof on the break
Yeah.
for further questions. We'll be back at 11.
Kul. Skitkul.
Ja, hej.
Hej Fredrik.
Hej, Olof. Du är från?
Jag är från Findwise, men jag är också från Göteborgs universitet.
Ja. Det är så lite alltså. Ja, jag var ju på en snackare där. Det är ju rätt spännande. Jag har ju... Ja, ja, fan.
Det är lite det som det handlar om också, expectation management. Ja, nu har vi
Jag har inga fickor, jag får hålla den.
Men det är bra, då vet man i alla fall vad man ska göra med henne.
Ja, hålla i.
Så det är liksom någon lärdom där liksom. God dagen.
Hej!
Tjena. Hur är det med dig? Jag behöver nog ett par koppar kaffe till, jag gick 4. Tog du tåget eller? Ja. Det var bra att tåget gick i alla fall. Ja. Det är inte självklart. Ulrika har redan fått smick.
Okej, får jag stå nära dig?
Jaha, du vill också säga något?
Ja.
Ska vi göra avdrag på vår tid så eller?
Funkar det med presentationen?
Ja, vi behövde
Justera
ändra
lite.
fontstorlek och sånt.
Ja.
Men den var inte så.
Nej, det var
Stor.
det största problemet var att hitta inställningen i Hebrew.
All right, everyone. Time for next presentation. I think I won't say that much. It's just Ulrika and Hannes will present from Naturvårdsverket and
Can we connect
Solutions.
the screen?
Yeah.
Which one is it?
Oh.
Jag tror att det var en mini DisplayPort. Är det?
Yes. All right. I just leave it to you.
Hello, my name is Ulrika Domler-Mattsson and I work at the Swedish Environmental Protection Agency, and we will speak a little bit about a project about decisions and documents as linked data. Swedish Environmental Protection Agency, we have a strategy for environmental data management. We have been working with this for several years, and this strategy we have together with other organizations. We have about 40 signatories to this strategy. It's both the county administrative boards and also several universities have signed this strategy. And we are working towards well-managed environmental data, and it's not as easy as it looks like. It comes down to, a lot comes down to metadata and master data issues. And from this strategy, in the implementation at the Swedish Environmental Protection Agency, we have worked with, we have a data policy and we have a strategy or a concept for metadata. And we have also worked with a process for making data available, which touches on several of the issues mentioned this morning earlier by Sky Life Lab Center. So the process has a lot to do with the security of information and actually the data management. The Swedish Environmental Protection Agency also has a mandate from the government with a digital first coordinating program. And it's for environmental services and the smarter services. It's a popular word right now in Sweden, to do things smarter. So we are supposed to do things smarter. And we do it by cooperation with other organizations. So we have been working a lot together with other organizations to discuss how we can work within different themes. In this, we have 3 different themes, and in one of these themes, we have been working with this project I will come into. We have been working with, in the process of making data available, we have seen that we have different types of data sets, which all are public sector information, and is then supposed to be made available as such. We have governmental publication, which are unstructured data and comes under the legal deposit of electronic material law. And those are made available in Libris. We have data sets in different databases, and we make those. We are working to make those available at öppnadata.se. But then we also have other documents which traditionally are in the archival systems. And sometimes, as in this example we will talk about now, it comes from a directive. This is from the Industrial Emissions Directive, which actually says in the law that we are supposed to make those documents available on internet. And this is why we started with this cooperation around those documents, because we were supposed to make those documents available on internet, but they were not regarded as governmental publications, since it was decisions. And then we had a group of people sitting and discussing what kind of metadata should be put on those decisions and other documents which the law said that we were to make available on internet. And this is when we started to work together with the Meta Solutions on this project, on making them available through Entryscape product. And I think I will leave it to you.
Yes, so read this. Yeah, I can tell a bit more about myself in the meanwhile. Hannes Evner, Meta Solutions, colleague of Matthias. Yes, so I've worked mostly with
Sorry, I forgot one.
Do you want to say something more?
I forgot this one.
Sorry.
This comes when you make the presentation very late in the evening before. I was to say something about also why we were working with the linked data. Sorry. And this is also because it's several reasons. For example, up to the right, we can see how the European Environmental Agency are working, the EEA. They have been working with the linked data for many years. And we have been doing some tests together with the European agency. So that is how we started to work with linked data in those projects. And after this, we started to work also with DCAT application profile we have a central metadata catalog at the Swedish Environmental Protection Agency, and we are sending information from this one. So we have done a mapping to DCAT application profile for sending data to the open data portal, öppnadata.se. And then it's also that we want to work with open data to do this progress in the steps of open data, to make data available in a more machine readable and linked way. So it's several reasons for us why we're working with this. But I can also say that it takes a long time. It's a change management process, I would say, within our organization. It's not easy. I would like to discuss this perhaps in the end of this day. It's not easy to make people understand linked data. It's quite theoretical, and it's not that easy to describe. And we have some actually difficulties with people who are very used of working in one way. They're used working with their SQL databases, and they don't want to change. They are very happy to do as they are used to. So I think this is a problem for progress for linked data, that it's not very easy to communicate, actually. So I think we should discuss this, how to communicate about linked data to make the progress faster. Yeah.
Should we check the next slide? So, hello, it's me again. So, the project that I will tell you a bit about is called, I don't know what the current name is, but LMD, NMD, Local Metadata, National Metadata. It's basically for collecting metadata about the decision documents that Ulrika just mentioned. So it's a perfect case for linked data. You have documents and you want to describe them with information. That's basically a sustainable way of providing metadata. So the core thing in the project is the decision documents. They are linked to resources like downloadable PDFs or related documents that you can request from the registration, for example. There are terminologies which are used to describe the content according to standardized vocabularies. There are some internal document types. There's a main document type, sub-document type, which is mainly in use at the agency. Then the related documents, publishing authorities, because it's not everything is coming from the EPA. And you know, the classical fields, what's the name, who did what when. Sometimes there was also information on who did what when and why, and things like that. So the information flow is quite simple. So it's basically from information publishers to Naturvårdsverket. And in this case, it is from the Länsstyrelser, which I guess is County Administrative Board, I guess. And also from Naturvårdsverket itself to Naturvårdsverket. So it's basically the harvesting process is quite simple. And I think the county administrative boards, they have a common infrastructure, so it's not 21 different harvesting points, it's actually only one in the current iteration. And yeah, what else? So it's I don't think that there are that many documents actually, but it's this is so it's one of the benefits of the current project was that there was not a lot of legacy which we had to take into consideration. So there was it was quite simple to come up with a metadata profile. In other projects where you have thousands or millions of documents, it's much more difficult to actually just push it into the same framework. So it's basically, now the picture is a bit squeezed, but it's it basically looks like this. The current test data is, well, it's decision documents, reference documents. Parts of it come from terminologies. We have what's the origin and so on. So how much time do we have left now? Is it?
Well,
We were 5 minutes late, so.
You've been presenting for 11.
Okay, good. This means that I can demo. How do I open a web browser here?
Oh, sorry.
Good. So.
Sure. I
Just give me the browser again.
I just wanted to close this one because it's annoying.
Okay. So, So I just show you the manual input of the information that is provided by Naturvårdsverket, because the county administrative boards are not going to use that interface, because the information is already in their own systems, which is exported into some XML format, which is converted into linked data then, and then it is harvested into this system. So one of the main reasons for using linked data is to be able to provide good provenance information. So having unique URIs that are actually constant over time. So if you have a decision somewhere out there from one of the county administrative boards, then you want to be able to point back to it. And that's why it comes in quite handy to have URLs. So if we look at this, for example, it's one of the easier descriptions. We have a related document from the European Commission. Everything is in Swedish. So the project, I don't think that the project will ever have translated information into English, because it's specific for national legislation. When entering information, you can choose between only entering mandatory information, which is quite sparse. So it's basically only document type, what kind of document is it, where is it, or which regions is it actually interesting for, who is the publisher, and that's basically it. So it's quite simple metadata form, which is good for the users, because, well, you know, everybody who has entered information into the metadata form knows that this is not one of the most fun things to do in a life. And then there are some additional forms, additional fields, like recommended information is actually quite big already. And then there are some additional ones that are optional. So if you have lots of information you want to, or you have to provide everything, then this can be actually quite a tedious task. And this is also important for reusability, because if you migrate from one system to another one, then of course you want to have a standardized way of expressing the metadata. So if that were an XML format, for example, it would probably be more difficult to map it into a new system. Yeah, so that's the local test catalog from the Naturvårdsverket, and then we have basically the harvesting target, which is collecting all of the documents from all of Sweden. The county administrative boards have not started yet. That's why there is only the test content from Naturvårdsverket right now. Any questions? Yes.
Maybe I missed something, but the data that you collect through this page, does it already come in linked data format, or it's non-linked data and then there is some process?
So the data that you see here and that Naturvårdsverket enters, that is original data that becomes linked data at the time of entering into the system. And when it's harvested from the county administrative boards, then it's harvested as RDF, which has been converted to RDF from XML source. So the only pieces of information that possibly could relate somehow to linked data are basically URLs that may exist in the source system. But currently there's no linked data involved outside of this system.
How many editors will be using this in the live experience?
How many users? Or
well, users. I mean, if you said that the entry of metadata will be time-consuming and not something that people prefer to do.
Yeah.
How many users will you have in the forthcoming system?
So I'm not sure how many users, how many physical users there actually will be at the agency, but I guess like you count. I guess will be able to count them with one hand. But somebody has to do it, right? So.
Yeah.
And I don't think that because it's very precise metadata, so you can't really try to extract information from all your existing PDFs, and so.
Okay. Hiring metadata slaves.
Yes.
How many people outside in the Länsstyrelsen? Do we know?
It depends if they will set up a joint metadata catalog or not. I'm not sure. I don't think they have decided yet.
How many documents in total?
So right now there are not that many documents because there is no historical data. So it's everything that is going to end up in the system is basically from now.
There's not going to be any kind of extractions from load from existing document archives.
No, I don't think so. So I think that there are no documents that could be extracted, and even if that were the case, then I don't think it would be possible to extract information with such a precision that would be necessary for legal documents.
So thanks.
Thank you.
So next presenter, Samuel, I think you can introduce yourself.
Yes, I will just switch the computer. Yeah. I'm supposed to have the mic, right? You have to remind me if I forget something. Which one was it? That, yeah. And how does it work? Is this okay? By the way, I can inform that there is a pointer just under here. Too late, but yeah. I guess we can keep it somewhere. So, Fernanda, are you starting 15 minutes now or already? Is it
Should
40?
I reset? Start.
Okay, I'll also. Right, so my name is Samuel Lampa. I'm a PhD student at in pharmaceutical bioinformatics. So I sit in the far corner of BMC over there. And I will, you see the title, I will talk a little bit about how I think that like data science and big data can come together with the world of linked data and semantic web and so on. And the reason I'm talking about this is that these two fields are actually what I'm working on. I started with semantic web stuff in my master's thesis like 10 years ago, and then I left it and have been doing like data science and data pipelines and stuff since that. And now it seems like maybe the technologies have improved a little bit, and yeah, we'll see what's the answer to this question. So I have this more detailed title that says a little bit more the names of some technologies here. So anyway, to start off the scene and kind of put out the problem, or one problem I think I have seen, and I will warn in beforehand that this talk it's quite much like personal opinion and my personal view and so on. So you're very much free to chime in with your view afterwards and so on. But I'll try to kind of give my perspective or my view from my perspective on this, as I have understood it. And as my impression of what has happened during the last 10 years have been that the semantic web, it started before the big data era, and so not the technologies that it was based on was not always very, maybe not, adapted to these terabytes of data and so on. So the idea is very much inspired from the web, that we have distributed, the information is distributed over the web. And then we have a user who is clicking and kind of interactively navigating. Of course, we have the idea of machine readability on top of that, of course, but still it's kind of, the information is spread out, and then of course, it's not easy to work with terabytes of data if it's spread out all over the world. So then we have, on the opposite side, we have had data science and especially big data where, yeah, maybe as you saw in Johan Rung's presentation, the data amounts are really just huge, and you can't build on strategies that involve shuffling around data. You need to keep things together and kind of shuffling it around locally as much as possible. So this is what I've tried to visualize here with, yeah, like some data processing and getting that into a nice kind of more high-level data set, and then doing visualizations and stuff. So it's a bit more like hands-on, getting your hands dirty and messing around with data. Another thing with the semantic web is that typically you work with data that is already published. So you kind of consume data, and it doesn't come very easy to you, like how do I mess around with data and try different ways of modeling the data and so on. That hasn't came very natural from the start, I would say. So, any solution to this? Just in text, a few more of the things that I already mentioned, like the data is distributed and so on. Also, a lot of technology. Yeah, I won't say more about this right now. So a few more of the things that I think have been challenging or added challenges to kind of working hands-on with data in the semantic web has been that like the tools perhaps have not been that developed, and also like since everything is spread out without one common schema, it's you kind of, if you start working with Sparkle, for example, to kind of query your data, you easily get tons of really large Sparkle queries, which are kind of one-off queries. I mean, what you want is to kind of build up some structure in this. In typical data science, perhaps you extract some data, and then you have a nicer data set, and you continue with that, and so on. So I think something like that is needed, and Sparkle, I don't think it perhaps has everything what is needed there. Basically what you would want is Sparkle and put a name on a query so that you can use this name and refer to it later as a concept or something. I'll come into that. So personally, I've been always very interested in Prolog, and this is a bit controversial, but I think it's really nice because it has these named rules. Like you can have a relation which you call grandparent, which is built up by other rules, like parent, for example. And here we have the parent relationship up here. And actually, it's very similar to Sparkle, actually. If you see this as a subject, and this is the predicate, and this is as the object. Yeah. And also, especially SWI Prolog has a very nice semantic web integration, and you can kind of, I mean, you can create these rules, and you can query Sparkle here inside the rule. Also external Sparkle endpoints and so on, and put a name on it, and then reuse that in other queries. So you can kind of build up a vocabulary, so that you can get more expressiveness and know what you're doing. So this is a direction I've been a fan of since the start, basically. So I'll mention quickly some things we did with this. In my master's thesis project, I integrated the SWI's Prolog into BioClips, which is it's a graphical workbench for bioinformatics and cheminformatics, which is developed in the group, in our research group. So yeah, and our experiences from that is the querying is nice and so on. The main problem with Prolog, and especially SWI Prolog, is that it does only store things in memory. So it's not suited for really large data sets. Something else we did while trying to kind of make it easier to mess around with data for normal users is to integrate or to make it possible to import semantic data into Semantic Media Wiki. I don't know, I guess everybody knows about Wikipedia. Semantic Media Wiki is not that well known, but Wikipedia is well known, and Wikipedia is powered by a software called Media Wiki. And Media Wiki, there's some extensions to that so that you can put in semantic data into Wiki in a very very nice and easy textual format. So we made a plugin so that you can import RDF in a lot of different ways and through some common code and get it into Media Wiki. So what it looks like is you kind of have your own local Wikipedia, and the Semantic Media Wiki is really nice because it has a lot of really nice features for like creating templates for formatting data really nicely and so on. So this screenshot is from a data set that we imported that was just some plain bioinformatics data. Then we imported it and then just created some templates, and then we just create the template once, and then all the things that in the wiki will be presented in this nice way. So it was kind of one way of being able to view the data in a user-friendly way. I mean, here we can click around, and then since it's a wiki, anybody can go in and edit and change the data and have everything stored in history and so on, and we can collaboratively work on the data, and then we can export it into semantic RDF format again afterwards. There's a Sparkle endpoint for getting the data out and so on. And actually, to link it to the Prolog world, here is a Prolog query querying this wiki, actually, with a Sparkle query. So that is also possible. So I'm coming towards the end of the talk, and that was some things we did. But today, I would say now when I'm coming back after many years of data pipelines and stuff, now I've been starting to look a little bit into linked data again, and I see that the field has progressed, luckily, during these 10 years. And there is some very promising solutions, I think, or technologies and stuff, for which are actually, they support working with pretty large data sets. And I think one of the things that has became clearer over the years is that to work with really large data sets, you have to be able to get data into your local computer or compute data center or something and mess around with it there. So these two tools which I mentioned here are supporting it in that way. And the first one is BlazeGraph, which is it's a triple store, but it's very fast. You can take a really large file in some RDF format, just drop it in the web interface, and it will import it in seconds, and then you can Sparkle and stuff. It's very, very slick to work with. Triple stores as a concept is pretty known already, so I won't say too much about it. More. I will tell a little bit more about RDF HDT, which is a newer thing. It's a newer thing and pretty bleeding edge, actually. So, but it's very promising, I think. And this is a binary format for storing RDF data. HDT stands for Header Dictionary Triples. So the idea here is that we have some metadata about the storage, then we have an index which is called the directory. And then we have the actual data, the triples, and everything is binary. And because we have the index, we can do search. Because we have the index separately, we can do very fast search operations on the data without actually needing to read through the whole file. So we have, for example, a 12 gigabyte file with 90 million triples or something, and we can do run the command line tools and get queries in, at least at the blink of an eye, we can say. Okay, I told some of this already. Blaze graph, HDT. And what is nice with HDT in relation to the powerful querying, which I mentioned before, is that SWI's Prolog supports it very nicely. It has a plugin for that. So maybe the main concern with it is that it's quite new and bleeding edge and so on. And also that if you need to turn data into this format, that is kind of a heavy operation right now. So it's not like with a triple store you can kind of write and read more fluently. Oh, by the way, I should mention that of course you can connect to Blaze Graph through Prolog as well. Anyway, quick summary to kind of describe why RDF HDT is needed. If we look at the typical way to store semantic data as a file, which would be XML or Turtle or notation 3, that's very inefficient, especially the XML and perhaps especially the N3 format. Since like 90 billion triples, that's, I don't know, it's hundreds of gigabytes, I think. And also if you need to do some operations on it, you need to do really large scans through the whole file. If you zip it, it will be compact, but then of course it's even slower to search. But with RDF HDT, you kind of get the best of both worlds. You get a really compact format that you can also search really fast. So I really like that. I don't have much time left. I don't have many slides left either. I should just mention that there's a big use case which is using RDF HDT, which I can recommend to check out. It's called LOD Laundromat, and LOD stands for something like the linked open data cloud something. So they basically took the whole linked data cloud, cleaned it up a little bit, and put it down into one data set. So that is really something to play around with if you have too little to do tonight. Lastly, something we did with RDF HDT already in a recent paper that just the last week came out is we made a small URI resolver, which is, we had quite a large data set. It was a 12 gigabyte file or something, and we didn't, it seemed like a good use case for RDF HDT. So in the future, my vision is to use Prolog more and more, SWI Prolog. It has also developed quite a bit, and it has these nice notebooks that you can use in addition to command lines and stuff. And then kind of, because I think that can be a nice integration layer for all kinds of data sources, since you build up your queries and stuff. That's my vision, at least. So before I come to the concluding slide, I want to say this quote by Tim Berners-Lee, which he has said it multiple times at recent talks, that linked data is the semantic web done right. So I think it basically reflects that the field has kind of matured a little bit and also now rebranded itself a little bit. So I'll end with this slide. I think I have like 3 minutes for questions, or is that right? Or?
Yes, that is right.
Moderate.
Do you know anything about the current status of BlazeGraph?
Not sure. I mean, I've tried it out and it worked great.
Yeah, because Amazon hired basically all of the engineers, and then they launched Amazon Neptune, and since then there was no development of BlazeGraph anymore.
And
I'm
that's,
just wondering whether
that sounds a bit worrisome.
dead or
Yeah, that sounds worrisome. I mean, it's open source and also it's used by Wikidata, which is a really major project. So I hope that there will be some incentives to put in maintenance of it. But I haven't heard about that yet. Yeah.
because I couldn't find any information about it, so I thought that perhaps you know.
Right. Let's hope for the best. Right.
More questions?
Have you thought about like copies of data, like in content delivery networks, or like why should there be copies all over the internet? Like, can you make a solution where you have, if you have one resource, for example, a JavaScript file, like, and it's that one URI, like.
That's a good question. That's a good question. Do you think about like individual resources or?
Yeah, like.
Yeah, you're not thinking about the data sets.
No, I think about resources. Like.
That's a good question. I guess it's something that the data publishers can think about. Like, and I'm not so good, very skilled in that. Yeah.
Maybe I can say, so this is actually one of the very contentious issues in linked data. This is one of the things that is hard for people who don't do linked data to understand. There is a long or very old principle coming from semantic web called AAA, which basically says that anyone can say anything about anything anywhere. So if there is a Wikipedia article, for example, about Marie Curie Skłodowska, and it says something about her, linked data fundamentally forbids you from assuming that that is the only place on the web that says something about her. You must assume, or at least you should assume, that there could be other places on the web also saying some information about it. And this is fundamentally why it's a little bit hard to do what you're asking. But true, it's problematic as the data science.
Yeah, I think what Wikidata has done with like gathering data is that they allow multiple conflicting data. Multiple conflicting data points, but they store the provenance information about where it comes from and so on.
Yes, a comment. So it's also this open world assumption, you can't know everything. I think that in each case it's possible to... Wait, take this one. It's possible to close the world. It's just that you have to decide which sources to include. And I think this connects also to Samuel's first reflection that it wasn't really mature and it's distributed and everything. And I think that's... yes, that's a valid point. Everything is distributed, but on the other hand, it uses HTTP. You can fetch it, you can cache it, you can do whatever you want with it. So one way is to actually have a cache, which we did one a couple of years back. Hannes did implement a linked data cache that, given a certain set of starting points, it can retrieve information and have this local graph where you can play around with it. So I think that there is just there is a need, or maybe you would have needed this kind of cache software to make things local, to make it easier to start playing around with. At least that's one of the problems you mentioned.
Okay. But getting the cache in an interactive fashion wouldn't be practical, I think, if you have terabytes of data.
No. You in this case, the cache is not interactive. It's more like you configure it. Say like, these are the sources, these are the relations you'd follow. Try these many times before you give up, and then you build up your. You close your world. You fetch your data that you can.
That would be really cool.
Yeah. I will send you a pointer.
Do you need that?
Yes. For the.
I need to hold it because Well, thank you. I'll keep time, but I'm also very conscious that I'm standing between you and lunch. I've introduced myself before. My name is Nanda, and I come from the National Veterinary Institute. So I am a veterinarian, very scared of talking to a more technical group. So keep that in mind. I don't come from the technical solution side. I come from the problem side. I don't have a solution, I have a problem. And a collaborator who tells me this is the solution for it. So I'm much more presenting the problem and how I think some of these, the world of linked data can solve it, but I don't necessarily understand enough about the technical side. I will be happy to hear different opinions through the rest of the day. I'm glad I come before lunch. And once you see the problem you have and the approach we're trying to give, I will be happy to hear I'm approaching it wrong or any ideas, or, well, I'm here to hear all of you. So I come from the veterinary side, and I feel like first I need to set your mind away from thinking this means we sit on a clinic and we deal with dogs. So we are Mediate. We are an agency tasked with population health in animals. So imagine imagine health from the perspective, I'm not talking about your doctor, I'm talking about the health of populations. I'm talking about people who worry about the population, not about an individual. So think you went to your doctor and he said you're sick. And then you come home and you get a call that says, because you're sick, you're not allowed to see anyone today. You're not allowed to go to work. You have to vaccinate, and if you're one of the anti-vax people, the police comes to your house and vaccinate you on brute force. That sounds really weird in humans, but that's exactly what we do with animals. Food-producing animals I'm talking about. So we worry about the health of livestock animals, food-producing animals. Those are commodities. Farmers keep them for economic reasons, and we worry about their health because they become food for people. So we have laws in place, and we are allowed to enforce, for instance, vaccine. We have a mandate by specific governments to take care of the health of those animals. And we design laws for what should be mandatory to vaccinate, when it should be mandatory to test them, what tests we have to do at a slaughterhouse for those animals to be fit for consumption. So that's the world I come from. And it used to be that people who do my kind of job, which we call surveillance, so we do surveillance of population health, we would decide how many animals we have to test a year, for instance, to find out what's going on, what's the level of disease in a population. But nowadays, we don't need to actively go on the field and collect data about a sample of animals, because data are recorded about these animals throughout their lives. So while the animals are being kept in a farm, there is data being recorded about them, and then they go to slaughter, and there is data being recorded at the slaughterhouse. If they see a vet, the vet has a record of that. It sends samples to a laboratory. The laboratory runs the samples to decide if the animal has disease A or B or C, and it records that. So data exists all around, but those data are being recorded for many different purposes, none of which is surveillance. The laboratory is only recording it in a database because they want to bill the person who sent the test. They don't even record it for the health purpose. The same with the vet. The farmer is only recording it also for economic interests. So there's a lot of sources of data. None of those were recorded for the purpose we want, which is to figure out what is the health status of a whole population. But the data are all there. So you have distributed sources of data collected for different purposes, and you're trying to make sense of all of it. On this kind of crowd, I don't think I need to sell the idea that that's a perfect target for an ontology. So we're trying to address the problem of making sense of those different data with a knowledge model that makes sense of those different data. End of story. My talk could end here for this crowd. But then, as we have seen through the different talks today, the problem isn't just data. The problem we have to solve isn't understanding the data. The whole problem we have to solve is the people behind those data and the organization behind those data and the political structure that are around. So if you consider, for instance, this is a picture of how we do Campylobacter surveillance in Sweden. So every chicken that is slaughtered, on the slaughterhouse, we collect samples to test if that batch of chicken has Campylobacter or not. Then that meat goes to a processing plant and then to the supermarket. Livsmedelsverket collects samples of chicken on the supermarket, tests for Campylobacter. If you eat that chicken and you get sick, you go to your doctor, they take a sample, a fecal sample, they send that to test for Campylobacter. So it's different agencies, and the healthcare ends up in the different communes, and the testing of each of those samples is done by in a different place, and they are all testing for the same thing. Do we have Campylobacter going on in Sweden? Now, there are samples collected in different places. Think about the life of one of those samples, the sample that is collected at the slaughterhouse. There is a design plan. We decide when and where we are going to collect those samples and bring them back to a central laboratory. Then we bring them back, we test, and we have laboratory results. This is just the life cycle of one sample, the ones that come to my institute, the National Veterinary Institute. And if you ask me where's the data about that sample being collected, well, I just recently went around the house trying to figure out. And it happens like this. We design the surveillance and we decide which samples are collected, and we write that somewhere in a text format, in a document that gets published as PDF every year. Then we decide what samples are collected, and when they're received, there is a database, a laboratory information management system that every sample information gets put on that database. But then if we decide to do whole genome sequencing, which is testing the whole genome of that Campylobacter we found, then there is a computer just to do whole genome sequencing. And then all the information gets stored in that computer. And the one girl who works with that computer has an Excel file in her computer where she links the IDs from that computer to the data from the other systems. And this is probably familiar to a lot of people who work with data. And once a year, we have a mandate to report all the cases of Campylobacter to the European Food Safety Agency. And that's for every European member state. And there are member states where there are people employed where 3 full months of their job is just translating data into the data models of the European Food Safety Agency, which change every year. So this is how data works now. For each sample, there are several different levels of information before and after the sample is collected. We have to report it to EFSA, the European Food Safety Agency, who publishes a data model. And we spend a lot of time coding our data to that harmonized data model. We don't necessarily code all the data. Some data gets lost. Some data only stays in our Word files. And then we send that to the European Food Safety Agency, and we get nothing back. We do it because it's mandatory to do it, but then the data is there, sitting with them. And it's sitting in a central database, but it's not fair data, as the European Union now decided to call it. It's not findable, accessible, interoperable, and reusable. I took notes from Matthias' talk in the morning, and he said we should use linked data to share, find, connect, and reason about data. And we are all coding data according to these food safety standards, but the data that sits in their database is just shareable. It's not, you can't reason with the data, you can't access, you can't find it. So the idea is that if we did have not a harmonized text model, that people are coding to those strings, but they are still strings, they are not things. Things in that database are still not things. If we had a knowledge model, then we wouldn't lose so much data in the process, and the data would be useful to each individual country. Instead of just going to EFSA, we would now be sending fair data to EFSA, and those data would be useful for us as well. That's the idea of how building a knowledge model could solve our problem. But the scene is the European Union is funding several different projects. And recently, a whole 80 million euros was put only into one health research. So that means trying to connect med and vet and food. And within those projects, there are 13 projects funded. About every of them has a pilot for how they're going to integrate data. And I think there is one that used the word semantic or ontologies into it. Because people are talking about sharing data, but they keep talking about let's all code after the same string. And if we bring in linked data, that's how they perceive it. That's how we see standards, right? And that's why we've stopped doing text standards. That's why we think our solution is different. But if we come to people and we say the solution is different, they think, oh, great, one more standard. And it's going to change again next year. So we are not going to be able to move forward unless we convince people there is a difference. And what we have to do is get one very specific case problem, build a little ontology for that, and implement it in a tool that shows people what is the difference between that and what they have been doing. So I am involved in one of those projects. It's a One Health integrative project. We received money from the European Union not to do research, but to do integration between med and vet. And if we build a knowledge model for one specific case study, let's say the Campylobacter surveillance that I showed earlier, if we create a knowledge model just to represent that one piece of activity we do surveillance for a lot of diseases, but we create a knowledge model to represent all the data in that one scene, and we show how much more powerful the data could be. Most of us who are in this room would like to do that. Sorry, this got tangled. Most of us see the benefit on the format of the data that we would have in the end. But the people coding those data, they don't really care unless we show them that we could reduce their burden of coding data into these harmonized standards. They're not going to care. So we're trying to design a little pilot where we have 3 years to do that. We haven't started. This is just a concept that people don't, another problem is they don't want to share their data. They want to send to the European Food Safety Agency just what's mandatory to send, period, and nothing more. So we have to have somehow a little interface where we welcome data in whatever format it is right now, and we allow the data to come out in different formats, sorry, not different formats, but with different targets. So the summarized data goes open, and the data that is private continues to be private. But now it's linked data, or at least it's data that we can reuse. And I think the presentation from Johan this morning, the first one, he put it perfectly when he said, if we were archiving not at the end of the process, but on the beginning. So what happens right now is we generate the data and we report to the Food Safety Agency at the end of the process. And then we do it only for their sake. But if we were handling data already in a better way from the start, we would store it in a way that is usable for us and for them. So I didn't realize that's when I put this slide together, I didn't realize that's basically what we had to propose. And it comes very timely because the European Food Safety Agency themselves realized that the reason they don't get the data they want is because they ask people for data at the end of the process. So they're trying to put an infrastructure together where people store data before they use, and then EFSA can go and they call it a data lake so that they can go and fish in the data they want. So they realized they needed to invert the process and get people to archive data on the beginning of the process, and then the data would be available for each institution and for them as well. But this is a lot of veterinarians talking around the table, and they didn't have any idea of the concept of ontologies and linked data either. So we're trying to put together these words into a way that makes sense. And it's a bit different because in the veterinary health, in the human health, usually people just hire the technical resources from outside. And in the veterinary health, it seems like we still keep trying to be veterinarians, web designers, and try to learn everything. And that's not working right now. So the reason, this is where my talk ends. I don't know how that solution would be built. I just know that what we need is better data at the end, but we're not going to convince people to come in with their data unless we solve their problem of coding data. So that's where we're heading. And yeah, that's all I had to talk about today.
Very interesting. now I think we all have a very much better view of the veterinary domain. So any questions? I have a comment immediately, and that's like this picture with 14 standards and 15 standards. I would love to draw a new one. I'm not a good drawer, but I would like to draw one which explains the difference in the semantic web or linked data context. Where, okay, we have a few old standards, but then, okay, we do new standards, but they are all based on the same linked data infrastructure, saying that, yeah, it's maybe we do something more because we have a little bit of a different need, but we're still reusing the same building blocks.
Well, but that's what we're trying to tell people, right? That, okay, everyone is coding their own data into this standard that is just a string standards too. So we keep saying, okay, let's not build one more standard, let's build this knowledge model that works with, everyone keeps collecting data the way they're collecting, everyone keeps doing whatever they're doing, and we're just going to have a place where we suck in data according to just different, we build the translation or the markup models once. And the thing is, we keep talking, but people think, yeah, right, in the end of the year, it's just going to be one more attempt failed of any standard. So I've been, Carl Hamar is not here, we've been working on this ontology for health surveillance for 2 years. And it hasn't gone very far because we still need people who understand the old standards to help us build a right knowledge model. And people are not willing to do that until they see that there is going to be a benefit. I sat with a group that is building a terminology for clinical research, and the person who keeps the terminology said, we have to move into description logics because I can't cope with the growth of this terminology anymore. So we went to London and we sat with them and we said, let's try to build, transform your existing terminology into a description logic one. And then people looked at us and said, we've given our times to so many solutions in the past. Why should we give our times to you? So then that's when I said, okay, we need to stop thinking we're going to address this whole problem and get one very specific problem. That sample I showed for Campylobacter, that's such a specific case. Let's get that one problem. And if we have 3 years, which we do, it's a lot of time. If at the end of the 3 years we have a model that works for how data comes in, how data comes out, then people are going to believe it. They need to see. They need to see what we mean with it's not more standard. What do we mean with the data linkable? It's too far from how they work with data for them to even understand how is this different or how is this better. So we need a working solution. We need a place where they go and see it.
So what you're saying is that all the code systems, I mean the standards that you have to codify accordingly to, I mean, are they publicly available as kind of terminologies that they will just import to their systems that they use today, or how are they kind of instantiated in their systems? Or are there spreadsheets? Or, I mean, how? So
EFSA distributes this XML model every year that may get updated every year. Right. And then you're supposed to fill in their XML model with your data. Right. And then you send it back to them.
Yeah, because I mean, I've been working not with veterinary, but with healthcare. In that we have obviously also terminologies. Like some of the and so forth, and if you make, I mean, as you say, you have to go back to the contributors to actually, make a semantic enhancement at contribution time to be, to level and surface and show them that. I mean, and it's doable. I'm just wondering how the format is, because then it should be doable.
Yeah, because whereas some data are sitting in Excel files, some data are sitting in a traditional database, some data is sitting nowhere. You would need to kind of create a little form for people to fill in the data manually, because right now nobody records those data. There's things that are already coded in some standard. It's fine, great. There are things that are not. There are things that are not sitting anywhere. But if you find a way to suck the data in whatever format it is, even it's in your head, come here and fill in this form for me. And then you can show that in the end, all the data are interoperable. Because people keep talking about data integration, data standards, but they don't understand the difference between that and interoperability. No. So if you don't do a case, if you don't show, here's what I mean. So that's our next step, is to do it.
Good. I think, yeah. I think this was very interesting. I would say it seems like what you're saying is that we need to be able to make small steps and prove that this is actually added value, and there needs to be some storytelling that is friendly for non-tech people to see the value. And that, okay, it's not new, but it's good that you remind us that it's something we need to be better at.
Yeah, exactly. And it's not easy, like for someone coming from a completely different field, if I try to explain to people, they say, okay, can I go somewhere and read about it? It's not easy actually to find good.
How have you modeled your knowledge domain? I mean, you said you've been doing that.
Yeah, it's not the surveillance one. We were trying to approach it from a different one. And it's just, I haven't come far along enough, because it's there are several different ontologies for different pieces of things, and getting them together has been a bigger challenge than I anticipated. Right. But I think I was approaching it from the wrong side. I was sitting and trying to model it, and we need to have a data, let's say a goal. This is the case we're going to do it for, and not start from the ontology, but start from the case.
So I think we need to wrap up. Was there some last question?
Over there.
Yeah.
So slightly different look at this whole thing. I know we didn't really talk much about RDF as a model and format. But did you consider using RML, RDF mapping language, to basically allow publishers or agencies to require XML and publish data in XML in a completely proprietary schema? And then you map the schema of that XML individually on a case-by-case basis. You do this effort, you produce this RML mapping file that tells basically how each part of the XML maps to RDF predicates. And then you basically, it's like a zero, it's not a zero cost, but it's a zero change, like zero breaking change way to what is known as RDF lifting, when you lift non-RDF data into RDF.
This can be done in many ways. I mean, you can do it with CSV, like table annotations, or database, relational database to RDF. So, I mean, that approach is really relevant.
I think because
again, you need to show the added value in the end of moving to that model, and that's, I think, what you are saying.
But that's the thing. Once you have a case, then you map the different ways data exist right now, and for each of those to come into this integrated space, then you may find one solution for each of them, and I definitely take note of that. I would take note of that.
So I think we'll break that there and take lunch, and of course grab a hold of Renata and talk to her during lunch. And we will be back around 1 o'clock.
I hope there are some signs for the people who need a special diet. Otherwise,
there is.
Contact me.
And we forgot to say, if you want to tweet, use this handle, LDSV 2018. You probably got it already.
We just outside.